Carl.
Thanks, Bob, for that very generous introduction. Could I ask for the lights in the audience to be all the way up, please? Good. I have this need to see my audience. Feedback. If everybody's sleeping, I know it's time to change the subject. Well, I'm very happy to be here and renew my long-term association with Stanford. I'm also very pleased at the conditions of the will of Mr. Bunyan. I read his charge as blending astronomy, astrophysics, photochemistry, geophysics, biology, and allied sciences to give a broad context to the human species in a way that the public could understand. And that's quite a task. I will do my best and even try to, at one point, mention a word that includes photochemistry. I'd like to do this talk in two parts. The first without slides, and the second with. Both of them intended in different but related ways to provide some sense of perspective and context. And both halves, in different ways, will address this issue of is there intelligent life on Earth, a question about which you doubtless have certain opinions of your own. It is a widely debated subject, nevertheless. Every human culture, without contact with its neighbors, has drawn the same conclusion about our place in the universe. It's extremely simple. You stand outside and you look up, and pretty soon, unless you're an extremely impatient person, you notice that the sun, the moon, and the stars are rising in setting. Rise in the east, across the sky, set in the west. The only plausible interpretation is that we are stationary at the center of the universe, and all of these bodies circle us. The sun is certainly a very impressive body. We recognize that light and heat emanate from it, and still, despite its evident power, it pays a kind of homage to us. Wow, we must be really something. It's very impressive. We are at the center of the universe. What's more, what is the function of the sun, the moon, and the stars? The only possible function is to help us. The sun lights, heats us in the daytime. The moon, there's an old Persian story about the wise vizier asked which is more important, the sun or the moon, answering the moon because it shines in the nighttime, whereas the sun shines in the daytime when it's light anyway. And the stars, you can navigate by the stars. You can tell when it's time to plant and when it's time to reap matters, and when the herds of wild animals are going to migrate, matters of life and death for our ancestors. So the universe was put here for us. And this naturally resonated with a sense of our own importance. There was a kind of geocentric conceit which arose all over the planet. And with the exception of a tiny blip associated with the name of Aristarchus of Samos. Everybody all over the world understood this to be true, and famous philosophers, famous scientists, leaders of religions, everybody, unquestioningly, we're at the center. We're important. We're wonderful. And if you could imagine a dispassionate extraterrestrial observer looking down on this world, with everybody saying daily, we're wonderful, we're at the center, they may have, you might think that they would consider us the planet of the idiots. Here's the Earth going around the sun, and the sun with its proper motion through the galaxy, and the galaxy fleeing as part of the Hubble flow, and all these little beings on this world. We're at the center, we're stationary, we're wonderful. That would be too harsh a judgment, because there was this unlucky coincidence that common sense observations and what we secretly wished would be true resonated, converged. And it was not until the 16th century that Nicholas Copernicus proposed the alternative model, and here he was cautious enough to publish it on his deathbed. And because there were penalties associated with demoting us from some central position. And the introduction to Copernicus's De Revolutionibus, written by a guy named Osiander, I think, argued like this. Said, now, I don't want anybody to get the wrong idea. Don't think that Copernicus really thought that the Earth went around the sun. It's not like that. We all know the sun goes around the Earth, as the Bible says. It's just that if you want to calculate where Mars will be in the sky 6 months from Tuesday, then there's an easier way by pretending that the Earth goes around the sun, even though it doesn't. And this was a view for the next century, century and a half of those who except for the most radical blowhards like Galileo. Galileo, using the first astronomical telescope, found some disquieting stuff. He found there were moons going around Jupiter. Big Jupiter, little moons. It seemed an analogy to big sun, little planets. He discovered Mercury and Venus going through phases, which is wholly incompatible with the standard Earth-centered universe with everything else laid out. There was a pathetic compromise proposed by Tycho Brahe, in which the sun goes around the Earth, but Mercury and Venus go around the sun, in order to explain the phases. But Galileo staunchly taught that Copernicus was right, for which the church took him to their dungeons and pointed out the instruments of torture, whereupon the aged astronomer, at least officially, abjured this abominable hypothesis. But time passes, the evidence becomes stronger and stronger, and well before the definitive evidence that the Earth goes around the sun, namely the annual parallax of the stars, which was discovered not until the 19th century, but long before that, the scientific and to some extent popular view made this very heavy transition from us at the center to the sun at the center. But every step was a kind of compromise in which people attempted to rescue centrality in some other way. And let me just give a few examples. This is in crude chronological order, but not precisely. Okay, so we're not at the center. The sun's at the center. But we're close to the center, right? I mean, because we're close to the sun is at the center of the universe. So we partake of centrality, maybe not as much as we want. And there's nothing else like the sun, right? And there's nothing else like the Earth, right? But then further telescopic observations showed that those other planets had features, clouds, and polar caps, and weird rings, and the idea that those were worlds on an equal footing with the Earth, but with different environments grew. And there were some people deeply depressed by that. And then the finding that the stars were suns just far away. And that since planets are small and shine only by feebly reflected light, maybe many, most, all of those other stars had planetary systems going around them. Okay, but we're at the center of the collection of stars called the Milky Way galaxy. And that's worth something. Don't knock it. But then observations in the 19th century showed that wasn't true. That we were in some pathetically remote spiral arm in the galactic boondocks. We couldn't even rescue a central position from that. And it turned out we weren't even the only galaxy. All those spiral nebulae turned out to be other galaxies as well. Then the expansion of the universe was discovered. And then for a moment, it looked as if everything was saved, because all those other galaxies were running away from us, as if we had some loathsome cosmic disease. But at least we were at the center. You could see it. And for a moment, it resonated beautifully with what we hoped was the case. But then it was pointed out perfectly properly that an astronomer in any one of those galaxies would see precisely the same thing, and demotion again. Now, not only was this deprovincialization of attitudes occurring in astronomy, but in many other fields. The most striking example is evolution. Okay, maybe there's nothing central about us astronomically, but as far as life goes, we're central. We're big time. We are the top dog. All the life on Earth was put here to serve us. And they are supposed to get out of our way, fear us, as the book of Genesis says. They're there for us to use as we like. And we are specially created. And a great deal of reassurance was drawn from us. But then 130 or so years ago, The Origin of Species was published, and it became clear that there was a mechanism which involved no supernatural intervention, by which it could be understood how all the beings on Earth had evolved by slow processes from much humbler beings. And with the publication of The Descent of Man, us too. Darwin was very cautious in The Origin of Species. All he said about our evolution was something like, and these ideas might prove relevant to our origins. That's as daring as he was willing to go in that book. But 10 years later, about 10 years later, he went the whole way and talked directly about human evolution as well. And in physics, from the time of Newton, it had been conventional to describe our velocity framework as a privileged frame of motion. That was the word used, privileged. Something special about our not position, but velocity. And Einstein, growing up in a Prussian-dominated Central Europe as a member of a despised minority, knew something about the emotional resonance of the idea of privilege and was suspicious of the idea from the beginning. And he started thinking, what would physics look like if there were no privileged frames of reference, and yet the laws of nature had to be the same from the point of view of every moving observer? And this is the central starting point of special relativity. So it could be argued, and there are a number of other cases like this, that many of the central debates in the history of science have to do with a challenge to the emotionally satisfying sense that we're somehow central or special. And in every case, these are not issues just argued by scientists off by themselves. The public is deeply engaged, almost always on the side of don't change anything, it's been bad enough, rescue at least a little special privilege, centrality for us. And in each case, the evidence, unfortunately for those who have that point of view, has gone the other way. Now, I don't want to suggest that that scientists get overwhelming evidence and then everybody agrees. Far from it. For example, the geocentric conceit is with us still. It's built into the language. The sun rises. The sun sets. I was up before sunrise. What is the locution by which, instead of pretending that we're stationary, we recognize in the language that it's the Earth spinning? Say, what, the sun passed below our tangent plane because of the spin of the Earth? I mean, some 4-year-old kid is gone by the time you try to say that. Be back before the sun passes below the tangent plane. Yeah, bye, Dad, yeah. We can't figure out a way to build it into the language. We're so geocentrically designed. It's so natural for us. We talk about the world, the world's series, the world. One of whatever it is, a billion worlds in the Milky Way, maybe a trillion. By the way, I never said that. That billions and billions stuff Johnny Carson said. I never said it. It's too imprecise. It's vague. There's billions and billions of stars. What is that? It doesn't mean anything. You say, 400 billion stars. Okay, now you're getting there. And when the Cosmos series was recently reconfigured for video cassette sales and a new updated version on the Turner network, I had to listen to everything I'd said. And I didn't think I said it, but who knew? And so I was sitting there on tenterhooks for all 13 episodes. Am I going to say it? Am I going to say it? I never said it. Where was it? Yeah. The world, the sun, the moon. See, the language has it built into it that what's around us is special. And as far as evolution goes, you know that there's, in this country especially, a devoted rear guard action to prevent it from being taught in the schools. There's a subject with the oxymoronic name scientific creationism, which, the first and second words contradict each other, which there are a lot of people very strong about. They don't want to hear we were evolved from ooze. Ooze. Ooze is not uplifting. Muck, mud. We don't want to come from there. Angels, that's where we belong. And I believe that that's the emotional roots behind the wish for us to be central. Now, this debate, the expanding wave of scientific progress engulfs in different centuries, in different ways, this same debate. And today, where is that debate? The search for extraterrestrial intelligence that Bob mentioned is clearly one. There are a lot of people who don't want there to be extraterrestrial intelligence, or if they're going to be there, they should be dumber than us. Because if they're smarter, especially a lot smarter, that's demoralizing. At least let us be the smartest beings in the universe. That's not asking a lot, is it? It's only 400 billion stars in this galaxy, 100 billion other galaxies. Maybe most stars have planets. For us to be the smartest isn't asking a lot. Sort of reasonable, don't you think? Also, maybe we're evolved from other beings, but there are characteristics of humans that are completely different, not matters of degree, but radical differences in kind from the other animals. Nobody uses tools except us. Nobody makes tools except us. Nobody is rational, none of those other animals. They can't foresee the future consequences of present actions. They're not altruistic. There's a list as long as my arm of things that are said to be special about us, enunciated by all the great philosophical and scientific figures in the history of the West, from Aristotle and Plato to Augustine and Aquinas to leading figures today, all of which turn out to be wrong. I mean, observationally wrong. Chimps make tools with a clear eye to what the future use will be. There is a chimp termite fishing industry, which involves a technology so difficult that Geza Taleki, a competent anthropologist and primate researcher, spent 4 months apprenticed to a chimp named Leakey in Tanzania in the Gombe Preserve, following the chimp around, watching what the chimp, so he could learn the technology. In the 4 months, nowhere. He couldn't do any of it. There were about 10 steps. He couldn't manage one of them. Chimps had spent, their entire lives watching other chimps do it, learning. Taleki had just been there a few months. It was hard. And likewise for the other things, the other characteristics, presumably making us unique. Now, I'm not pretending that there are chimpanzees who have jet aircraft or nuclear weapons or other signs of high intelligence. But remember, we didn't have those for most of the tenure of humans on Earth, and biologically, we were the same 100,000 years ago as we are today. So building a civilization can't be what distinguishes us. And it's hard to find what it is. Maybe it's language, except chimps and bonobos are showing great facility these days. And there is even a gorilla on the Stanford campus alleged to with Amislan, talk well. Another area of this dispute is what is called the anthropic principle, where a desperate attempt, in my view, is being made to rescue some centrality for us. The argument is, if you change, in your mind, nobody knows how to do it in reality, the laws of nature, or change the values of the fundamental physical constants, then in many cases you produce a universe inimical to the evolution of human beings. Thus, stars, you don't get stars. Or atoms don't hold together. Or you get stars, but they evolve through their entire stellar evolution in a week. And so life is impossible. Now, there are two ways of looking at this. One is, yes, we are the product of the kind of universe we live in. What did you expect? And the other is the laws of nature and the physical constants are made the way they are in order that we shall, 15 billion years later, evolve. And if that were true, then that rescues the entire anthropocentric conceit. Maybe we're not at the center, but the laws of nature were designed for our benefit. You can't look up and see it by the motion of the moon, but if you're a really smart physicist, you can examine the laws of nature and see that it was all made for us. One of the many deficiencies of this argument, and for the reasons I've just mentioned, in a historical framework, we should be suspicious of it from the beginning. The human interest is too clear, is that no one has made a systematic effort to look at all those other hypothetical universes and see if they're consistent with some quite different kind of life than us. And, it's a very hard thing to do, of course. But the idea that if the precise sequence of events that led to us is not duplicated, then life is impossible. It's like, saying that if extraterrestrial intelligent beings are not Presbyterians, then they're not intelligent. We could imagine that they don't have to exactly follow cultural motifs of our civilization and could still be smart. Okay. Well, it's been a painful history. And the pain is still with us. Many people compare this idea of a universe unstructured for us with the idea that comforting, helpful, warm, friendly, family-oriented universe in which everything was done for us. And of course, the latter is more friendly than the former. But it seems to me we have an obligation to understand how the universe really is, because the universe has no obligation to conform to human conceit. I'd like now to narrow the focus and talk about a particular question, which, as I said before, most people believe, and for good reason, they know the answer to, and that is there intelligent life on Earth? Now, what I mean specifically is, if you were an extraterrestrial being examining the Earth from space for the first time, would you be able to detect life? How easy would it be? Would you detect all the aspects of life we consider important, or just some minor or frivolous aspects of life? Now, this is something that I enjoyed speculating on for many years, but of course, difficult to actually do until there was a kind of failing in NASA. Namely, it was unable to send sizable payloads to the planet Jupiter just on rocket oomph alone. And so to get there, had to do gravitational assist maneuvers in which you fall into the gravitational potential of a world, and it speeds you up. And if you do your gravitational billiards right, you eventually can speed up so that you can get to Jupiter, which otherwise you might not do. The mission involved is called Galileo. It's on its way to Jupiter, and it made 2 close passes to the Earth. By close, I mean a few hundred kilometers from the surface. And 1 close pass to Venus, as I say, only as a propulsion maneuver. But it seemed to me that here was the opportunity I'd been waiting for. Let's turn on those instruments and look at the Earth and see if we can detect life. The instruments are all designed for looking for Jupiter, and therefore, this is a way to calibrate the conclusion tentatively drawn from other missions as we fly by world after world that there's no life there. It's a suspect conclusion unless we've done the control experiment of looking at our own planet and seeing if that we can indeed detect life. So in the remainder of this talk, I'm going to to mainly use the Galileo results. For the very high resolution pictures, I won't, because Galileo's greatest surface resolution was about 1 kilometer. But for most of it, I will, and I won't always say where the pictures come from. But as I say, most of them are Galileo. So I asked you to free your mind of all prejudice and imagine that you have no idea what kind of a place the Earth is. The first data, except its distance from the star and so on, come from this flyby. What can you find? So the first slide, if we can have the lights out now, is for orientation only. So here we are. This is our moon. Notice that the artist has neglected to draw any of the other moons of 60 other moons or so. Here's Jupiter, where Galileo is going, and to do it, it did something like this. Well, it has to go around the sun. And finally, it gets to Jupiter. Next slide, please. Here is a lovely photo taken just last January of the Earth and the Moon together by Galileo. And here we have a resolution of, a few hundred kilometers or something like that. It's a blue and white planet, and beyond that, hard to tell what's happening, at least just from looking. Next slide. This is not a Galileo picture. As I say, I'm not going to announce what is and what isn't. Here you can see that there is evanescent white stuff in the atmosphere. Clouds, just take a picture 10 minutes later, and you'll see that there are some changes, a few hours of big changes. There's some blue stuff, and there's some brown stuff. The blue and brown stuff doesn't change. The white stuff does. I can't tell if there's anything alive here. Can you? I mean, there's certainly meteorological interest. There is, if you look closely, a permanent polar cap. It's something that freezes out down there where clearly it's cold. Colder, that doesn't freeze out, or at least not as much, up here. What is the evanescent white stuff? What is the polar cap? What is the blue stuff? What is the brown stuff? That's certainly something you would want to find out about. This picture is taken in ordinary reflected visible light. The next picture is exactly the same view from the same satellite. Next slide, please. Taken in the thermal infrared. Here we are looking at the emitted infrared radiation of the Earth, in which the temperature scale is grays are cool, and reds are hot, and yellows are still hotter. And sure enough, it's pretty hot here, except for this region, which was covered by clouds in the previous picture. And this region is covered all the time with clouds. And what we are looking at is, at 10 microns, the thermal radiation of the Earth being emitted pretty unimpeded to space. The next slide shows the same view again. Next slide, please. But at a wavelength of 2.2 microns, where carbon dioxide and water vapor absorb, and you can't see anything about the surface. You're looking entirely into the atmosphere. And this means that you don't know that it's carbon dioxide and water yet. I'm occasionally going to slip and say what we know from other data. I'll try to be explicit when I do that. And this immediately means that there should be a greenhouse effect. That in the infrared, there are places which are opaque or semi-opaque to the infrared thermal radiation that the Earth tries to radiate to space to cool off. And as a result, the mean temperature of the Earth has to rise to a higher temperature than its equilibrium would otherwise be. You can readily calculate what the equilibrium temperature ought to be just from the heliocentric distance of the Earth and its albedo, and find that it is some 30 degrees centigrade warmer than it ought to be. And the obvious answer for that 30 degrees centigrade is the greenhouse effect, but which molecules are responsible? Next slide. Here is Galileo data. And the first thing I want to point out, this is from 0.7 to 1 microns in the very near infrared. This is an intensity scale. And you can see this set of absorption features due to atmospheric water vapor. You can quickly calculate that the amount of water vapor implied by... I wonder what that noise is. Implied by these spectra is the amount you'd expect in equilibrium above a watery planet. And therefore, the idea of the oceans are water, that the clouds are condensed water vapor, and that the polar... Is that the sound system or just somebody getting up and down? And that the... There's a no on the radio. A no, I'll say. If I say put over here, nothing will happen, huh? Okay, I guess I'll do that then. And that the polar cap, well below the freezing point of water, is frozen water. So that's very nice. We've identified this this important constituent of the Earth, and in fact, it's unique. There is no other water-covered planet in the solar system. Now, there's something else that shows up here at about 0.75 microns, the so-called A band, and that is molecular oxygen, which is another unique circumstance. No other planet has any significant amount of molecular oxygen. And immediately we have to ask, how does it come about that there is all this molecular oxygen? Where does it come from? Now, the first thing you'd think about is, and here I'm going to do a photochemical remark, is that it's the ultraviolet photodissociation of water vapor. That UV photons come in, break the water apart, the hydrogen atoms escape to space from the upper atmosphere or exosphere, the oxygen builds up, and that's why you have 20% molecular oxygen. But when you look at that in detail, including worrying about oxidation of the crust of the Earth, it gets to be very difficult, maybe not impossible, but very difficult to understand how, over all of geological time, you could accumulate that much oxygen. And if that's the case, if there are not enough UV photons from the sun to break water apart enough, then you have to do it some other way. There are many more visible photons than UV photons, but a single visible photon doesn't break water apart. You have to add two of them up. And there's no non-biological way of doing that. But if you had biology, if it could use two visible light photons to break a water molecule apart, releasing the oxygen, then you could explain it. Now, this is not I don't want to pretend this is a very strong argument. There are a lot of uncertainties if you don't have ground truth. But the large amount of molecular oxygen is a hint, supports a suspicion that there has to be life on Earth, and it would have to be very widespread in order to grab so many photons over geological time. Now, the infrared spectrum gives us another hint of life in quite a different way. Next slide, please. Here is the infrared spectrum from 2.4 to 3.8 microns, and here from 4 to 5.2. And notice the presence of methane, nitrous oxide, carbon dioxide, all greenhouse gases. And in fact, those greenhouse gases, along with CO2 and water, very nicely explain the observed greenhouse effect. But I want to say something about the 3.33 micron methane feature. Maybe I can have the lights for just a minute. is the chemical equilibrium for methane in the presence of an excess of oxygen is to convert the methane to carbon dioxide in water. It just gets oxidized, and it does it very quickly, and there's no kinetic barrier to it. And you can then calculate, I'll show you a table in a minute, what the thermodynamic equilibrium abundance of methane ought to be in this excess of oxygen, where it would naturally tend to. And it's something like 1 methane molecule in every 10 to the 135th molecules in the Earth's atmosphere. The mixing ratio should be 10 to the minus 135th. But there are not 10 to the 135 molecules in the Earth's atmosphere. In fact, there's nothing like 10 to the 135 elementary particles in the entire universe. It's only something like 10 to the 79th or 80th. So this is the same as saying that there should not be a single molecule of methane in the Earth's atmosphere. And yet, make a little survey, the molecules right here, excuse me, which kind of you, which kind of you, which kind of you, you find that 1 in a million are methane. So that's what, 129 order of magnitude discrepancy, even in planetary astronomy. This is a significant discrepancy. And what must the answer be? It must be that methane is pouring out of the interior of the Earth at a rate so fast that it overwhelms the tendency of thermodynamic equilibrium to oxidize the methane. Now, what must those sources of contemporary methane be? First of all, you look at Mars and Venus, and there's essentially no methane there at all. So those planets are not making methane. The 2 other planets closest to the Earth in a wide variety of senses. And in fact, now my brown tooth hat is on. In fact, all the sources of methane are biological. Leakage from natural gas and petroleum wells, that's old biology. And there are a whole bunch of new biology, bog methane, methane bacteria in bogs, as an ancillary to the cultivation of rice. And I'm trying to put this delicately, bovine flatulence. Now, think for just a moment. Here's a spacecraft zooming by the Earth, trying to find life on Earth. And what shows up, among other things? These intimate intestinal activities of ruminants. It is not high on our list of what we consider the most important activities of life on Earth. We might not have guessed that that's what's detectable. I don't at all pretend that you see a 3.33 micron feature and you conclude, aha, bovine flatulence. But still, it's very unexpected. What we consider important and what shows up don't agree terribly well. The next slide shows a table of the thermodynamic disequilibria. Lights down. Next slide, please. And I underestimated. It's 10 to the 145th. So it's 139 orders of magnitude discrepancy. In other areas, what Galileo found and what are the standard ground truth values are just the same. And it's just another way of saying that Galileo was able to characterize for the molecules it detected what we have here. Now, I want to move to a quite different area. Next slide, please. And that is photography. Can you find by looking signs of life? What would you be? By the way, there's a fundamental reason why flash photography of projected slides won't work. Let's go to the next slide. Next slide, please. Now, when the Galileo imaging system has a wonderful filter wheel in front of it with lots of filters, and we can take pictures in any 3 filters we want, and then reconstruct a color picture in which, let's say, we assign the 0.72 micron channel to blue. And as long as we make pictures simultaneously in 3 colors, and then convert it into blue, green, and red, we can make lovely color pictures which will show up what absorbs in the right region. When we take such pictures of the Earth, we find that there are, crudely, 3 general kinds of regions on the continents of the Earth. Area A, in which there is a steady increase in reflectivity with increasing wavelength, slightly reddish surface material, which is consistent with a wide range of minerals and mineral assemblages. That's the geology part of the lecture. And an area B where it's flat through some of the visible, but very steep right here in the end of the red. And then area C, which is extremely steep at the red edge at 0.7 microns. And this means that there is some widely available pigment which is absorbing in the red. And there is no mineral or mineral assemblage known which plausibly can explain that. And therefore, this pigment is presumptive evidence of life on Earth, and maybe is the pigment that absorbs the visible light, so you can add up 2 visible photons in order to photodissociate water and explain the oxygen as well. So I want now to show you 4 specially prepared and garishly colored Galileo photographs of the Earth, in which areas with this steep absorption are colored orange. Next slide, please. So here is South America and Central, some of North America. And we could focus this just slightly, please. Good. And you can see that ground truth hat on again, that for vast regions of South America under the white clouds, there is vivid oranges. The Cordillera and the Andes are gray. They are not heavily vegetated. The rest is. Notice in Amazonia, which used to be deep orange, there's lots of fading of the orange. By the way, the magenta colors are, because of the water vapor band in this region, the magenta colors are cloud-associated water vapor. Next slide. Here is the Central Pacific, Australia, New Zealand, Tierra del Fuego, and what's this? Maybe Hawaii. And the little bit of land that you can see has New Zealand certainly looks heavily pigmented. We're just going to move around the Earth. Next slide. Here is Australia, and the little bit of pigmentation we saw turns out to be an anomaly. The vast bulk of it is not pigmented, not vegetated. But Indonesia certainly is, Southeast Asia certainly is, India certainly is. Next slide. And here we are at Africa. Maybe focus again, please. You went too far, go back. Okay. And here you can see the Sahara and the Saudi Arabian desert, unvegetated, a sharp line of demarcation between desert and vegetation. There's a transition region. And there's some clouds, but there's a lot. This was all very heavily vegetated at one time. Can't see much, but Namibia and the Kalahari Desert into Botswana. Over here you can see not very highly vegetated. And if we had a time series of pictures of this sort over the last few decades, we would see the orange diminishing. So The Earth turns out, from this kind of photography, to be loaded with biological pigments, photosynthetic pigments, and of course, the pigment in question is chlorophyll. It's the red band of chlorophyll, and if we had had filters for there, the blue band would have shown up equally well. Now, next slide. I want to go to a different way to look for life on Earth, namely to see it directly. Let's go to higher and higher resolution pictures of the Earth and see if we can find, at what point do we find signs of life? So not to be parochial, this is where I live, right there. No sign of life or intelligence at all. This false color photography, which is a conventional that will be used in a number of other pictures, has liquid water black, clouds white, and vegetation red. Next slide shows a perfectly typical situation in which there is a break in the surrounding vegetation and big cities turn up as dirty. It's mainly non-vegetated. I don't know if you can see it, but there is a kind of rectangle of red right there, which is New York Central Park. At this resolution, a few kilometers, something like that, no sign of life. Next slide brings us to California. This is the Salton Sea. This is the Imperial Valley. And those of you not beyond the Rayleigh resolution criterion will make out that there is a kind of checkerboard pattern of reds and blacks here, which looks on the verge, at least, of showing something highly geometrized. When you get down to, this is about 100-meter resolution, when you get down to tens of meter resolution, suddenly, all over the Earth, deserts and oceans aside, similar related patterns show up. Next slide. This is Oregon, and these are circular, irrigation is not the right word. You know, they spray water with these circular things. There's a technical word, I've forgotten it. And all over the planet you see circles, squares, rectangles. Triangles are in short supply. And I'm not sure what an extraterrestrial would deduce. I guess the most that could be deduced is that the dominant organisms on the planet, whoever they are, have a simultaneous passion for territoriality and Euclidean geometry. Beyond that, you would not know much, but that's already quite far along in understanding us, I think. Now, if you could do better, next slide, please, and go to, say, 10-meter resolution, then the geometrical patterns become glorious. This is a spot imaging picture of Washington, D.C., and the question long debated about whether there's intelligent life can be answered tentatively in the affirmative. You'll recognize that this is the run through the famous part, including the nation's capital. Lots of straight lines, and not just lots of straight lines within the cities, but lots of straight lines connecting the cities. In fact, the straight lines crisscross the planet. There's huge numbers of them. It's clearly important. If your resolution could now improve another order of magnitude, so you get down to 1-meter resolution, you would find that the straight lines are clogged with little beings, very patient, one behind another, that at night shine 2 little lights in front of themselves so they know where they're going, and sometimes go into little houses to sleep at night. Some of them, unfortunately, just sleep out on the street. Sorry. most of them seem to sleep out in the street. Homeless dominant organisms is the conclusion, but they have clearly rearranged the planet for their own convenience. And we extraterrestrials would take great pleasure in finally plumbing the resolution depths so that we can actually see the dominant life forms on the planet. And in fact, we could do better than that. There's a kind of parasitology we can do, because if we got to better than a meter resolution, you could see little parasites entering and exiting the dominant organisms. I think we would have every reason to be extremely satisfied with ourselves. Okay, I want now to mention two more signs of life on Earth. The next one is visible light at night. This is visible light in daylight. What happens if you photograph the Earth at night? Next slide, please. This picture, of course, was, I don't know if that was a groan or an ooh. This picture, of course, was not taken all at once, since this is a mosaic, but it's in Mercator projection what the night side of the Earth looks like. So let's try to quickly go through it. The brightest region of the Earth at night has absolutely nothing to do with life or intelligence. That's the aurora borealis. Everything else, every other spot of light you see, is due to intelligent life. You can see this lovely outlining of the shape of the major continents, conforming exactly to what we see in the daylight. For some reason, the dominant beings have lit up the continental margins. And we know that they're cities. We looked at that one. If you look closely right here, you can see us talking right here in this room. And you can see that there are continental interiors that are not lit up, but lots of places are. I want to show you two, there are several, but two kinds of lights at night not due to cities. One you can see here in North Africa and the Middle East. Those are not extremely densely populated with city lights. What we're looking at there is the burn-off of natural gas and petroleum wells, the flaring. And it's very interesting that is, and this is, of course, time variable. And it would, in the long term, many pictures like this show up as something different. Take a look now at Japan. You can see it illuminated stem to stern. The only other as densely lit place in terms of cities is right here in Western Europe. But I want to call your attention to this. You see this triangle right here? Now, what is that? That's the Sea of Japan. That's not cities. That's not even land. What is it? Can I have the lights, please? That is, in fact, the Japanese squid fishing fleet. They shine bright lights at night over a vast area of ocean so as to trick the squid into thinking that it's daylight. The squid come to the surface and there get killed. It's a mass murder of invertebrates. In fact, another way to say it is, one of the signs of life on Earth visible from space is sushi. Who would have figured? Sushi is visible. Look what isn't visible, but sushi is. Now, the other way in which life was detected by Galileo, this, by the way, is the Defense Meteorological Satellite. This is not Galileo data. Galileo has a plasma wave spectrometer which detects radio emission designed for the synchrotron emission from the trapped radiation belts around Jupiter. But what it found, as we approached on the night side, above the plasma frequency, that is at a frequency of 4, 5, 6 megahertz, is a set of modulated radio emissions. Because it's above the plasma frequency, it can be coming from the surface. Because it's at night, the ionosphere is not the electron density is not very high. As you fly by the planet from the dark to the light side, the ionospheric electron density increases and the signals go away. And it is very hard to understand that in terms other than technology and intelligence. And it may be, it's not clear, it may be the very low frequency radio signals that the U.S. Navy gives to distant nuclear armed submarines. Let us assume that's the case. Now, look at what's visible from space. Bovine flatulence, sushi, and the means for launching missiles that can, any one of which can destroy 200 cities. Now, and some other things, as I said. Now, that just isn't, at least my sense, of the significant science of life on Earth. You cannot see an enormous amount of our art, music, literature, culture, science, compassion from this altitude in this way. It's a kind of parable of what gets seen and what doesn't. In any case, the conclusion is wildly positive. You can, from a spacecraft like Galileo, detect life on Earth, many different aspects of it in many different frequency ranges, and therefore the negative conclusions drawn with similar instruments from other planets are probably right. We have calibrated the search for life on other planets, and our solar system says nothing about other solar systems. Now, having gotten this far in your search for life on Earth, it would make sense to go into orbit around the Earth and to look more closely and to look for changes. And I just want briefly in the remainder of the talk to give a sense of that. Next slide, please. So here is the delta of a river in Madagascar choked with topsoil. And in fact, the rate of loss of topsoil into the Indian Ocean is so great that you can calculate from this and other rivers in Madagascar that you can calculate that at this rate, there will be no more topsoil in Madagascar in another few decades. And something similar, not this spectacular, is true of many places on the Earth. The extraterrestrials would discover that we're permitting to be lost the kind of soil necessary to grow the vegetation. Surely that seems bad. Next slide. This is former Czechoslovakia and former East Germany, but it could be any industrialized place. And you can see enormous amounts of industrial pollutants and carbon dioxide pouring out of smokestacks into the atmosphere. The next slide is a twilight photo of the Amazon basin. Every spot of light you see here is forest being burned down. And again, you could do a calculation which shows that these vegetated places, these bright orange spots, especially at regions, especially at equatorial latitudes, are being lost at a phenomenal rate. Cannot go on for very long until there's none of it left. Couldn't have been happening for long, otherwise it will all be gone now. We have arrived at this planet at some critical time in its evolution when the dominant organisms are putting themselves at risk. The next slide shows what you could determine from Earth orbit. This, in fact, was determined from the ground. The annual variation in the amount of carbon dioxide in the atmosphere. The up and downs are due to the northern deciduous forest putting out leaf, which takes CO2 out of the atmosphere, and then the leaves falling off in fall and more CO2 going in. So there's an annual oscillation, but the overall trend is alarmingly steep. The amount of carbon dioxide being poured into the atmosphere, consistent with burning all this vegetation and fossil fuels. But we know CO2 is a greenhouse gas. And the next slide shows that not only is this happening for CO2, but for methane. The cows are busy. And for chlorofluorocarbons, which are not only a potent greenhouse gas, but also, we would perhaps know, an extremely effective agent for depletion of the protective ozone layer. So something really strange is happening on this planet. They're denuding the topsoil. They're destroying the protective ozone layer. They're polluting the atmosphere, and they're doing an uncontrolled and massive experiment on the climate. Put all this together, and it surely would be necessary to reassess the preliminary conclusion that there's intelligent life on Earth. I haven't given this lecture very often, but I have a few times before, and when I stop here, I find it's a real downer. So I will not stop here, and I want to try to end on an up. So permit me just 2 more slides. The next slide is, focus please. It can't be focused too much, but we can do better than that. No, other way. That's it, that's it, that's it. Okay. This is the last photograph taken of Neptune and its enigmatic moon Triton as the Voyager 2 spacecraft left it after its epical journey through the outer solar system, photographing and obtaining other data of 60, roughly, worlds, many of them brand new to us, the opening of the outer solar system to the human species. These 2 Voyager spacecraft and 2 spacecraft that preceded them, Pioneer 10 and 11, have such high velocities that they are inexorably going to escape from the solar system and become the first artifact of the human species to make for interstellar space. They're traveling very slowly, surely, but nevertheless, it is a triumph of our engineering that we're able to do that. And an example of what our science and technology could do given a real chance. I wanted, from the early days of the Voyager mission, to look back and try to take a picture of the Earth from the outskirts of the system. Finally, Voyager only was guaranteed by the manufacturers to work as far as Saturn. But again, because of the brilliance of the JPL engineers and the fact that they got smarter faster than Voyager got dumb, it worked at Uranus and it worked at Neptune. And only after this picture was taken, only after we passed Neptune, was I able to convince the project to turn the cameras back and take one last look at the Earth and a few other planets. I didn't imagine that there would be a great deal of science, but I thought, nevertheless, we could learn something from that picture. And so my last slide is the result. This is Venus, Jupiter, Saturn, Uranus, and Neptune motion smeared. And here, momentarily in a sunbeam, is the Earth. Look at that. That's us. A pale blue. Everybody you know, everybody you love, everybody you ever heard of, every human being who ever lived there. Every couple in love, every hopeful child, every prince and pauper, every professor and student, every corrupt politician, every revered religious leader, every conqueror intent on empire lived on that little blue dot. Again, our pretensions are manifest. Astronomy is sometimes described as a humbling experience. And I believe that's what this picture says. To me, this blue dot is fragile, vulnerable, and a reminder to us that we have an obligation to care for and cherish this world, the only home our species has ever known. Thank you.
Thank you very much, Carl, for a wonderful trip to the universe. Now that we all know how important we are in the scheme of the things, or how intelligent we are as a species, you're all invited to ask some questions. If you have any self-esteem left, then you can muster the courage. Please go to one of the microphones in the aisle. Go beforehand and we'll take questions from different aisles.
I'd be glad to answer questions on anything I've been talking about, or anything else that you think might be of interest. And I ask you not to be demoralized by the talk. I was just that was reality. I didn't mean it to be demoralizing. We can, if we want some way in which we're special, in which we're significant, then it's up to us to make that way. And we can certainly do it. I was arguing only against an undeserved central position, something that we want through no dint of effort on our part. Yes?
Yeah, did you mention what would be centered as radio and TV frequencies? Is that
No, you're absolutely right.
did give away?
We didn't have we didn't have detectors at those frequencies, but in fact, the Earth is ablaze at those frequencies from that little part of the radio band that gets through the ionosphere, television, military radar, and astronomical radar. All of that gets out, not only easily seen by a spacecraft a few hundred kilometers from the Earth, but detectable over interstellar distances, which is one of the reasons why it makes sense to listen for possible signals from other civilizations. If our inadvertent radio leakage at our relatively new radio civilization can be detected with our own level of detection equipment at the nearest star, then more advanced civilizations might be detectable at much greater distances. Yes.
One thing you didn't mention is whether our little probe would notice that there's other stuff in orbit.
Whether there's
whether it wasn't alone in orbit. After all, we've put a good.
it was a flyby. It wasn't in orbit, and no, nothing like that. There's a lot of debris up there, but very little of it big enough to see. Remember, a kilometer resolution at a few hundred kilometers away. So in space, you would have to have a kilometer-sized spacecraft only a few hundred kilometers away to be detectable, and there are none, as far as I know.
Yeah, I'm wondering,
Talk into the microphone so everybody can hear.
might we assume that if there's intelligent life out there, that they're friendly? I mean, we just visited this planet, and we see how we have treated other species on Earth, and that seems to be much closer to home than some other species. Mark even broadcast signals intentionally so that they can detect it, or should we remain very quiet?
This is a general category of question which often gets asked, and I don't know, which particular model you had in your mind, but what a lot of people have in their minds is, don't give away our position because the extraterrestrials will come here and eat us. Because we eat guys, we eat other animals, so they'll come here and eat us. Let me say why I think this is nothing to worry about. First off, what is it that's worth crossing interstellar distances about us? Do we have such a delicate flavor that it's worth crossing these immense interstellar distances to get here? Seems to me unlikely, but I could be wrong. Suppose we are a gourmet's delight. Why not just steal one human being, sequence the amino acids, and manufacture the sequence on your home planet? Why have to steal lots of human beings? It's just a question of cost effectiveness. Now, another concern, which comes most people having a deep understanding of human nature, is that extraterrestrials will recognize that sooner or later we'll be a danger to them. And maybe they should come and preempt. Not what you're thinking.
No, I mean, if they can make it to.
Here is the Earth in absolute radio silence for 4.5 billion years, except for an occasional sporadic auroral kilometer radiation or something like that. And then suddenly, starting in the late 40s with widespread commercial television, there gets to be an expanding spherical wave traveling at the speed of light a light year a year, and then encompassing the nearby stars. And right now it's 45 light years out, and there's whatever there is, 45 light years out, hundreds of stars, something like that. Maybe it's more than 1,000 already. And if there's anybody there, they will listen to find out what this is. And what will they hear? They'll hear howdy doody, Milton Berle, the Army McCarthy hearings, and other signs of intelligent life on Earth. I'm sometimes asked if there's a lot of intelligent life, how come they aren't here? Now you know. It's a sign of their intelligence. I'm only joking. But in any case, it is absolutely too late. And a lot of times you get letters to newspapers saying, for heaven's sake, astronomers, you don't know what you're doing. Keep quiet. You'll give us away. Those letters should be directed to television stations, to the Department of Defense, and to planetary radar. And I'd like to suggest that Len Tyler, who's in the audience, would be glad to hear any complaints about planetary radar. Only joking. I think this kind of question is interesting because it's a kind of Rorschach test. We project on the extraterrestrials what we're worried about ourselves. And for good reason, for perfectly good reasons. Just as the Orson Welles 1938 broadcast about alien invasion was a concern about what was happening in Europe, and that's why the resonance was so high. These questions illuminate what we're worried about ourselves. Well, if there are, there's a question.
Yeah, I wanted to ask you, we're getting really good at looking at ozone holes and increasing CO2 and all that. Do you have any, good ideas of what we can do with this information other than inform the public? I mean, so if we know that the ozone hole is getting bigger, people's, we're still using our cars. And I mean, legislation is slowly occurring, changing this, but do you have any insight as to what other things we can do with this information?
Informing the public, but in a democracy, that's what you want to do. I mean, see, the theory is that the people run the country and the people in Washington work for us rather than the other way around, which is more often the reality. But to the extent that the Jeffersonian ideal is valid, then the people are exactly who we should be talking to, because we're the guys at risk. The bureaucrats will just stay inside the Capitol and let other people go out for them. So what can we do? First thing we can do is absolutely ban chlorofluorocarbons and kindred compounds that are efficiently destroying the ozone layer. You know how it works. I got a lot of things to say on this. I'm trying to bite my tongue. The CFC molecules, precisely because they're so inert, they were brilliantly designed. They don't occur in nature because they don't chemically react. That was the reason they were safe. Survived to the stratosphere where, more photochemistry, where they are photodissociated and the released chlorine atoms preside catalytically over the destruction of large numbers of ozone molecules. Remarkably, I mean, in a way, it's astonishing and very hopeful. The principal industrial nations of the planet have agreed to phase out CFCs, and they did it in the Montreal Protocol before it was completely clear that there was a substitute that could run our refrigerators and our air conditioners and so on. And for industrial nations to do that under such circumstances is a sign of how dangerous it is. It's not talked about as that dangerous, but the fact that it was done in, 87, is a clear indication of how dangerous it isn't. And it's dangerous for 4 categories of reasons. One, the one you hear about a lot, increased skin cancer. And especially for light-skinned people like me, absolutely right. If you have more melanin, you're better protected. And skin cancer is serious, likewise cataracts. That's one category. A second, much more serious category is that prolonged exposure to ultraviolet light compromises the human immune system. And in that sense, it's like AIDS. And the third way is that prolonged exposure to increased ultraviolet light attacks the primary photosynthetic producers, the plants at the base of the food chain, the phytoplankton in the oceans, who have to live right near the surface in order to harvest sunlight, but then they are not protected against ultraviolet light. A few centimeters of seawater doesn't absorb the near UV. If they go, then the zooplankton who eat them go, and the little fish who eat the shrimp who eat the little fish, and the shrimp who eat the zooplankton, and the little fish who eat the shrimp, and the big fish who eat the little fish, and then dolphins, whales, people at the top of the pyramid. All of that, for all we know, might unravel. Similarly on the land, it's very serious, and the stopgap, so-called HCFCs, which do not destroy the ozone layer nearly as much, still do. And the big danger there is that you put the CFCs in the atmosphere, and it's about a century before they go away on their own. So stop by the year 2000, which is the present goal, and by 2100 we can go out of doors. I'm exaggerating, but so anyway, the thing we can do is pretty much being done. It ought to be sped up a little bit, but apart from that, we're doing it. Global warming is much more difficult because there, it's not just taking on the DuPont company, the principal manufacturers of CFC, it's taking on principal sources of income for the owners and workers in the coal, oil, gas, auto, rubber, and chemical industries. Put those together, and that is a very potent political force. And so that by itself means this is much tougher sledding. If we were serious, we would be committed to much more efficient use of fossil fuels. Why do we drive 25-mile-a-gallon cars when you could drive 50, 70, 90-mile-per-gallon cars? That technology is within reach. Fluorescent instead of incandescent lamps, and so on. That's a vast area where we save money, greater efficiency, and also free ourselves of this slavish dependency on foreign sources of petroleum, which causes wars, among other things. Every reason to do it, even if you didn't buy the global warming greenhouse argument. Then beyond that, alternative sources of energy besides fossil fuel, including solar electric, wind turbines, biomass conversion, hydrogen fuel, and so on. I don't include nuclear power on that list, although it's perfect as far as the greenhouse effect goes, because it has other problems. That's what we ought to be doing. That's what President Clinton 2 days ago moved in a small way towards. We will reduce our CO2 emissions by the year 2000 to what they were in the year 1990. Okay, better than the opposite. And that's the sort of thing people ought to be encouraging governments to do. And also, there is a way to discourage corporations by not buying the products that destroy the ozone layer or produce global warming. So that's a very long answer. I'm sort of I'm spring-loaded for that question. Thank you for asking. Yes.
We seem to think of intelligent life, of potential extraterrestrials on our own terms. Is there any valid reason to project our concept of sentience and our assumption that all life should be carbon based on extraterrestrials?
There is nothing in this argument that I presented that is based on that kind of chauvinism. Thermodynamic disequilibrium you could have with life based on anything. If the surface of some planet was covered with, I don't know, silicon-based giraffes, if they made big geometrical reworking of the surface of that planet, we'd see it. That doesn't depend. That doesn't make assumptions about the kind of life. Likewise, radio transmission. So I don't think we're as parochial as there might be a tendency to think we are.
One last question about what do you think is the most important aspect of the space program right now? Is it programs like Galileo or Cassini that go out to far planets and look at them, or is it exploration such as the manned mission to Mars, which a lot of us here are concerned about? Or is it other mission to planet Earth type things which look back on the Earth?
For the question, I will be talking tomorrow on the. You got roller skates. Another sign of intelligent life on Earth. Roller skates are great. You don't take them off when you come into lectures? I mean, you might have to leave fast. My greatest difficulties are in justifying the manned and womaned program. And I'll talk about the arguments pro and con tomorrow. They clearly involve the largest amount of money. And for that reason are immediately vulnerable themselves. The other things that space does, and let me not restrict myself to NASA, but broaden it. Let me just briefly mention and see if I believe that everyone resonates to at least some of the things on this list. I think it's wildly cost effective. Communication satellites which link up the planet. We can talk to almost anybody on Earth now. The deprovincialization of the most distant countries happens because of communication satellites. Weather satellites, which save billions of dollars every year in just the avoidance of crop losses by a little lead time to farmers to take precautions. Military reconnaissance and treaty verification satellites, which calm the paranoids and hotheads on all sides. Worth their weight in gold, as Lyndon Johnson once said. Satellites that monitor the environmental health of the Earth, which we're just beginning to do in a serious way. Satellites in Earth orbit that look out, that like COBE, for example, which address some of the most profound questions of the origin, nature, and fate of the entire universe, questions every human culture has asked one way or another. And then the thing that I like, spacecraft that visit other planets for their own sake, but also to compare them with our own. I think all of that makes, even in rather short-term sense, a terrific investment. Even if you didn't have an ounce of exploratory spirit in you, and I can tell from your question that you do, but even if you don't, it would make sense to support NASA in these things. Sending people is the place where the arguments are not as clear-cut, and that's also where it's most expensive. Yes?
Dr. Sagan, I think we're done.
No, go ahead.
After all that you've seen and experienced as a scientist, do you believe in God? A timeless creator, something that is omnipotent,
Good.
something that you cannot prove empirically, probably.
Now, wait a minute. If I can't prove it empirically, how could I believe in it if there's no evidence?
There's no empirical evidence. Do you have any
What other kind is there?
faith?
Faith. But faith means belief in the absence of evidence, right? That's
Correct.
what you're saying. That is what you just said. So then people could believe in absolutely anything without evidence. And would that be okay to you?
Well, the types of evidence I was thinking of were not necessarily scientific.
What kind of evidence is there besides scientific? I don't mean to
Well,
put you on the spot, but
No, no.
what kinds of evidence are there that's not scientific?
Just personal feelings, maybe personal types of revelation. Anything that you have experienced in a spiritual realm.
Okay,
Outside of the classroom.
let me not argue with you, but try to respond to what I know you want to hear. But I personally have a problem with the idea of gut religion based on revelation, so-called, because anybody can say that God told them anything and justify any kind of statement with no self-correction. And the most impressive aspect of the scientific method is that it has a built-in error correction machinery, and that humans are deeply vulnerable to error. That's why experimentalists check their instruments. That's why scientists check each other's results. That's why graduate students go through agonizing PhD oral exams. That's why when we submit papers to scientific journals, unpleasant referees reports come back to us. This is the built-in error correction mechanism designed to steer us away from fallacy, including the fact that we are fully capable of deceiving ourselves. I find none of that error correction machinery in bureaucratic religions. Now, having said that, let me answer your question. I will now talk on the basis of evidence. There is a wide range of quite different ideas which go under the same rubric, God. And let me give you two end members of that spectrum. One is that there is an outsized male with white skin and a long white beard who sits in a throne in the sky and tallies every sparrow. I have no a priori problem with this idea. And in a way, it takes me straight back to childhood. But it's like my grandfather. But I know of absolutely no evidence, absolutely nothing that supports that notion. None of our spacecraft have photographed. Just nothing. The other end member that by its practitioners is called God is the God of Einstein and Spinoza, which is pretty closely the sum total of the physical laws of the universe. It would be madness to deny that there are physical laws of the universe that apply everywhere. I mean, 10 billion light years away. Same gravity, same quantum mechanics. Very impressive fact. But if that's what you mean by God, then of course I believe in God. The evidence is superbly good that there are physical laws. Have I answered your question? See, on the issue of creation, you gave a very good few word description. There is an open question of whether the universe needs a creator. And let me just say a few words about that. First off, if you say, yes, the universe was created 15 billion years ago from nothing, and I say, how was it created? And you say, God created. What happens when I say to you, and who created God? You might say, well, wait a minute, that's not fair. That's beyond our ability to understand. why not save a step and say the creation of the universe is beyond our ability to understand? What exactly is gained by saying that some being about whom I have no other evidence called God created it? And if you say nobody created God, God was here always, then why not save a step and say nobody created the universe? The universe was here always. Again, what exactly is it we learn from the notion that God created the universe? So I don't pretend to have answers to these questions. I mean, the notion of the universe being created from nothing and the notion of the universe being infinitely old, both are very hard to grapple with intuitively. And likewise, if you replace the word universe with the word God. But that's at least some of the way that I go about thinking about these knotty questions, and I'm glad you raised it. Thank you. Yes.
Chemistry.
Terms of the Bunyan
Right.
lecture.
I wondered if you also would address psychology. A while ago, you wrote in Parade magazine about the phenomenon of the stories of people being kidnapped by extraterrestrials. And one of the things I appreciated about the article is that you didn't just say, well, these people are crazy. You examined it as a human psychic phenomenon over time. Would you say a little more about your thinking about it?
Okay, well, as maybe some of you know, I'm not opposed to the idea of extraterrestrial life. I think it's a fantastically interesting subject. It illuminates our view of ourselves in the universe. I've invested some effort in trying to see if it exists with spacecraft and with radio telescopes. Nobody would be happier than me. And there is this low-level rumble since 1947, mainly in the United States, saying we're being visited, we're being visited, we're being visited. And lately, there's a newish wrinkle, or at least it's gotten to epidemic proportions lately, in which people say, not only are we being visited, I personally, they say, have been abducted by small gray beings with very large eyes and expressionless mouths, taken aboard their flying saucer and experimented on for unspeakable sexual purposes. And it was an awful experience, and I'm sorry to have to tell you about it, but in the interest of truth and fairness and so on, I would like to go on your television show and tell the world about it, something like that. Now, I have met with some of these people. I met with the prototypical experiencers, Betty and Barney Hill, who claimed to be abducted in the 60s. And the first thing that's clear is these people are feeling deep emotions. This isn't just, ha ha, let's play a little hoax. Something emotionally profound, doesn't mean that there's any corollary in the exterior world, has happened to them. And for that reason, there is some level at which they should be taken seriously, as you were saying. But I ask myself, I don't know if you know, the UFO enthusiasts commissioned a Roper poll, the conclusion of which was that 2% of all Americans have been abducted, even though most of them don't know it. And it's easy to do a little calculation to show that over the last 40 years, unless the aliens have some special preference for Americans, that somebody's been abducted every second all over the planet. It's surprising that more of the neighbors haven't noticed. So the issue is, bearing in mind our profound ignorance about hallucinations or other unfamiliar internal states, and our profound ignorance about extraterrestrial life. I mean, we're ignorant in both cases. If you had to choose, which is more likely? That we're being invaded by alien sexual abusers, or that there is an unfamiliar mental state that hundreds, maybe thousands, maybe more of people, mainly Americans, are experiencing. And if that's the choice, the answer is clear to me. I mean, people do hallucinate. People hallucinate. It's a fact. And I myself, I lost my parents, both of them, about 10 years ago, a little more. And about, I don't know, 6 times since then, I'll be walking or doing work or something. And just for a minute, I hear one of them saying, "Carl," just that. But it's clearly either my mother or my father. And I heard that so many times in my childhood. It doesn't seem to me that there's anything so peculiar about having a vivid recollection of it. And children hallucinate all the time. Monsters. The shadow in the closet is a monster. Every 2-year-old, 3-year-old, 4-year-old feel that. I'm positive that most people in this audience, if you think back, will recall vivid, frightening hallucinations in childhood. There's no reason why all of us should lose that altogether in adulthood. I think it's something like that. And what's more, it's of great scientific interest. Among other things, touching on how easily we can be misled, touching on the origins of religion. There is real scientific pay dirt here, but it's not about extraterrestrial life.
The SETI project had discovered unequivocal evidence of extraterrestrial life, we would have read about it in the Stanford Daily. But has there been any tantalizing anomalies that perhaps aren't conclusive, but that might hint of I Love Lucy reruns from another civilization?
No, except for the I Love Lucy, the answer is yes. There certainly have been tantalizing events which pass some criteria for extraterrestrial intelligence, but the thing about them is they do not repeat. And a signal that does not repeat cannot be examined by skeptical colleagues. You cannot test it, that it's really from way up there and not a glitch in your electronics, and therefore it is close to worthless. If we had such a thing and it stayed around for a few days, that would be completely different. But there are much more capable surveys going on now than were available ever before. And hang on, maybe we'll find something.
Do you think, as a species, we're faced with the possibility that the Earth cannot support indefinite population expansion? Will it come to the point where we have to turn the Earth into a nature reserve, essentially evacuate large portions of the population?
2 other worlds, you mean?
Yeah.
Okay. First question to ask is, what is the disparity of births over deaths on the planet? How many more people are born than die every day? And the answer is 250,000. So if we were to make a significant dent in world population growth by shipping people to other planets, we would have to ship 250,000 people, or a little less, off the Earth every day. You will recognize that this is significantly beyond NASA's current capabilities, or any capabilities of all the spacefaring nations at any foreseeable time in the future. Therefore, we cannot possibly, in the foreseeable future, address population growth by shipping people elsewhere. We have to solve the problem right here. I believe this is a soluble problem. And without going into the details, the key part of it is to increase the economic self-sufficiency of the billion poorest people on the planet. If you're worried about world population growth, you have to be worried about economic injustice. This all has to do with what's called the demographic transition. If you want to look that up, I don't want to spend the time right now to go through it. Have I answered your question? Thank you. Yes.
Does our move away from egocentrism in biology have any implications in your mind regarding our use of animals for food and research, among other things?
Hard to see that it wouldn't. You know, Darwin's view was that the idea of an unbridgeable gap between us and the other animals plays the function of not making us unhappy when we kill them, eat them, wear them, and so on. And if we recognize the deep connections, then it would be more painful for us to treat the animals as if they were our property that we can deal with as we like. And I think many people would say, well, you got to draw the line somewhere. And the question is, where do you draw the line? The fact that chimps and bonobos now look to be so similar to us is making it very hard to draw the line between them and us, I think. And the question of why all over the planet chimps are in jail is an interesting question. Now, the further the phylogenetic distance from us, for most people, the more easily we can kill, mutilate, whatever we want, the animal or plant in question. And I don't want to pretend this is something other people do, not me. I eat meat, and I enjoy it, and I recognize that our ancestors did, and it's built into me. But it's become a somewhat less enjoyable experience especially since I've written Shadows of Forgotten Ancestors with Annie Drian.
I'm from Europe, and
where in Europe?
Sorry, Ireland. Some of us are taking down borders, and others of us are putting up borders. The question is, do you think that we'll bring our borders that we have on Earth with us into space? And is there anything we can do to stop it if we are?
I apologize. The key word that you used 3 times that sounds like borers, I didn't understand.
Borders.
Borders.
Lines between countries.
Borders, yeah. Separate this country from this country. Right. Thank you. It's a remarkable fact that it's so hard to see national borders from space. It's so clear that these are man-made and nothing natural. Also, it is a remarkable fact that carbon dioxide and chlorofluorocarbon molecules are too stupid to appreciate the profound idea of national sovereignty. They effortlessly cross borders. You produce CFCs in Seattle, and the people in Argentina are getting fried. In that sense, the planet is one, and the national boundaries don't count at all. And in trying to deal with the environmental problems, it's completely clear no one nation can do it. Suppose there's a very powerful and upright nation. I'm not going to make any more CFCs. I'm going to make wholesale conversion to alternatives to fossil fuels. What do they get for their trouble? Almost nothing, if nobody else does it. So these problems are not created by any one nation or generation, and cannot be solved by any one nation or generation. We're reaching a point where the problems that face us are fundamentally planetary, global, and all solutions must be planetary or global. And that means, this is not an ideological point, like it or not, the differences between nations are going to erode. It's clearly happening all the time. The European Economic Union, in which Ireland is a willing member, and Britain somewhat less so, is one example. The Montreal Protocol on CFCs that I mentioned before is another. The worldwide spread of the AIDS epidemic is another. It's another thing that doesn't obey national boundary.
and communications, transportation,